Hello students, first question from the chapter work, energy and power. A force F equal to 20 plus 10y acts on a particle in y direction. Here force acting on a particle along in y direction, where F is in Newton and y is in meter. Y means displacement of the particle, that is along y axis direction. Units are meter. Work done by the force is to move the particle. We are going to find out the work done by the particle from displacement along y axis, y equal to 0 to 1 meter. This is the given question. So note down what are the given. Force F equal to 20 plus 10y along y axis, and displacement y equal to 0 to 1 meter. Find out the work done. Here force is given in the form of equation, so I am going to use the work formula W equal to integral of F ds, where F is force, ds is the displacement, but here displacement is along in y direction, so I am rewriting as F into dy. Here displacement from y1 to y2. So substitute that values. W equal to F value 20 plus 10y into displacement dy. Here y from 0 to 1 limits. So I am going to integrate the equation. So integral of 0 to 1, 20 into dy, this is the one part, plus integral of 0 to 1, 10y into dy. So here 20 is the constant, so integral of dy equal to integral of dy means here constant is there, I am taking as 1 into dy, y plus constant. So 20 into y integral of 0 to 1 plus here 10 into integral of 0 to 1 y into dy. So integral of y into dy. Here y power n I am taking as integral of y power n into dy, I am taking as y power n plus 1 by n plus 1. Here constant into dy, that is y plus constant. Here y power n into dy is equal to y power n plus 1 by n plus 1. Here constant, here y power n. We are integrating here with respect to constant. Here integral y power n. Okay. So here n value is 1. I am going to substitute y power 1 into dy integral of y power 1 plus 1 by 1 plus 1. So y square by 2. So here 20 into y integral of 0 to 1 plus 10 into y into dy. Integral of y into dy means y square by 2, limits 0 to 1. Now I am applying the limits at y. 20 into upper limit minus lower limit. Upper limit is 1 minus, in case of y lower limit is 0. 1 minus 0 equal to 10. So here apply the upper limit minus lower limit. In case of y, upper limit is 1 square means 1 by 2. Lower limit is 0 square by 2. So 20 minus 0, 1 plus 10 into 1 by 2. Here total term is 0. How many times gets cancelled? 5 times. 20 plus 5, 25 joule is the work done value. This is the answer. Now see the options. Option C is the correct answer, 25 joule. Second question, body A of mass 4m moving with speed u. So first body A of mass 4m moving with speed is u collides with another body B of mass 2m at rest. So I am taking as this is the object A having mass 4m moving with speed of u. Next, what is the object B? Object B of mass 2m is at rest position. This is about before collision. The collision is head on and elastic in nature. After the collision, fraction of energy lost by the colliding body A is. Here object A collide with the object B. So here fraction of energy lost by the colliding body A. We are going to find the energy lost by the colliding body A. Okay. If you are going to find the fraction of energy lost by the colliding body A means we are going to find the kinetic energy. If you want to find out the kinetic energy, we want to final velocity of the body. So formula for final velocity V equal to m1 minus m2 by m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2. This is the formula. V equal to, this is the m1, this is the m2, this is the u1. So u1 velocity is u, u2 velocity is 0. So substitute that values. m1 4m minus m2 2m by 4m plus 2m into u1 velocity u plus 2 into m2 is 2m by m1 plus m2 4m plus 2m into u2. u2 means object B velocity is at rest position, so u2 value is 0. So this term is going to totally 0. V equal to 4m minus 2m, 2m by 4m plus 2m, 6m into u. m gets cancelled, 2 1s through 2 3s. So V equal to final velocity 1 by 3 u. This is the final velocity. Now we can easily find the fraction of energy lost by the colliding body A. So when body is A is colliding to body B, so the energy is converted into kinetic energy. So we are going to find the kinetic energy of fraction. Fraction of kinetic energy loss by the colliding body A. So formula for kinetic energy lost by the body A, Ke I initial kinetic energy minus final kinetic energy KEF by initial kinetic energy KEI. So equal to kinetic energy formula 1 by 2. So this is the initial kinetic energy m u square 1 by 2 of m v square by 1 by 2 m u square 1 by 2 m u square minus 1 by 2 m. We know that already final velocity value, its value is 1 by 3 u. Final velocity value is whole square by 1 by 2 m u square. On numerator I am taking common as 1 by 2 m u square. So 1 by 2 m u square is the common term on numerator. So here total 1, here 1 by 2 m u square is the common term. So 1 by 3 whole square 1 by 9 on denominator 1 by 2 m u square. So 1 by 2 m u square 1 by 2 m u square gets cancelled. 1 minus 1 by 9, 9 minus 1 by 9, so 8 by 9. So fraction of kinetic energy lost by the colliding body A is 8 by 9. See the options. Option B is the correct answer, 8 by 9. Next question. A moving block having mass m collides with another stationary block of mass 4m. The lighter block means mass of m coming to rest position after collision when the initial velocity of lighter block is v, then the value of coefficient of restitution will be. Coefficient of restitution means we are going to find the E. For example, I am taking, this is a moving block of mass m. This is the stationary block of mass 4m. This is moving with initial velocity u. This is before collision. It is its rest position. After collision, the lighter body coming to rest position, the heavier body is going to be in motion with velocity v. This is after collision. This is before collision, this is the after collision. First of all, I am going to calculate here law of conservation of linear momentum. Law of conservation of linear momentum. So according to law of conservation of linear momentum says that the sum of bodies linear momentum before collision is equal to the sum of the linear momentum after the collision. So before the collision, both bodies, the sum of both bodies linear momentum is equal to the after the collision of sum of linear momentum. So I am taking as m1 u1 plus m2 u2. This is the before collision. m1 v1 plus m2 v2 is the after collision. I am substituting here values. So first body of mass m moving with velocity u, second body of mass 4m, it is at rest position, so velocity 0. First body of mass m is at rest position, so velocity is 0. Second body of mass 4m, its velocity after collision is v. So this term is going to zeros. So what are the remaining terms? m into u equal to 4m into v. So here m gets the cancel, u equal to 4v, v equal to 1 by 4 u. So the final velocity of the heavier body is 1 by 4th of initial velocity of lighter body. But what we are going to find the coefficient of restitution value. The value of coefficient of restitution will be E. What is the formula for E? Velocity of separation. Separation means after the collision of velocity of approach. Approach means before the collision. So before the collision is velocity u, velocity of separation, final velocity is 1 by 4 u. I am written as u by 4 1 by u. This is the u, this is the 4. So u gets cancel, 1 by 4. So coefficient of restitution E equal to 1 by 4 means 0.25. Now see the options. 0.25. Option B is the correct answer. Next question. Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. Here raindrop is falling from a height 1 kilometer. The mass of the raindrop is 1 gram. It hits the ground with a speed of 50 meter per second. Take G constant with value of 10 meter per second square. The work done by the, we are going to find the work done by the raindrop, gravitational force and resistive force of air. So when raindrop is falling down, two types of work done is going to happen. One is gravitational force and resistive force of the rain of air. So first of all, what are the given here? Mass of raindrop m equal to 1 gram. Next to height h equal to 1 kilometer, speed 50 meter per second, G equal to 10 meter per second square. First what we are going to find out? Work done by the gravitational force. So I am taking work done by the gravitational force as Wg equal to, its formula is nothing but equal to potential energy mgh. So mass, I am converting 1 gram into kg, so 10 to the power of minus 3 kg. So 1 kg equal to 1000 grams, 10 to the power of 3 into g. We want to 1 gram equal to 1 by 10 to the power of 3 kg. It can be written as 10 to the power of 3 minus 3 kg equal to 1 gram. So 1 gram equal to 10 to the power of minus 3 kg. Okay. So Wg equal to mass 10 to the power of minus 3. Next to height 1 kilometer. It can be converted into meters because speed is also given in meter. G value is also in meter. So 1 kilometer is equal to 1000 meter. So height equal to 1000. Next G value 10. So here 10 to the power of minus 3 plus 3 going to cancel. So 10 joule is the work done by the gravitational force. Next we are going to calculate the resistive force of air. So work done by resistive force I am taking as WA. When water drop is falling from a height 1 kilometer, so its potential energy mgh is equal to, we are going to find the WA equal to mgh minus 1 by 2 mv square. We know that already mgh value 10 joule minus 1 by 2, mass value 10 to the power of minus 3, velocity value 50 meter per second. So 50 whole square. 10 minus 1 by 2, 10 to the power of minus 3. So 2500. So how many times going to cancel? 1, 2 2s 4, 1250. So 10 minus 1250 into 10 to the power of minus 3. 10 minus, here 10 to the power of 1, here minus 3. So here 10 to the power of minus 2. 125 into 10 to the power of minus 2. 10 minus 10 to the power of minus 2 into 125 can I written as 1.25. So subtract 10 minus 1.25, 8.75 joule. 8.75 joule. Here this is the water drop, it falling from height of 1 kilometer. Force acting on the water drop this direction, air resistive force acting this direction, both are in 180 degrees. So when the two forces are acting in opposite direction, their work done should be negative. So their work done should be negative. WA value, work done by the resistive force by air, minus 8.75 joule. So work done by the gravitational force is positive 10 joule. Work done by the resistive force of air, W equal to minus 8.75 joule. So here negative work done is going to happen. See the options once. First one is the gravitational force 10 joule, that is positive value. Resistive force of air, that is negative value. So 10 joule, second one is minus 8.75 joule. So option C is the correct answer. Next question, a spring of force constant K. So I am here, one spring is taken, the constant of spring is K, that is original, is cut into length ratio 1:2:3. So this spring can be cut into 3 parts, the ratio is 1:2:3. are connected in series and new force constant is k dash. When these three springs are connected in series, their new force constant of spring is k dash. Then they are connected in parallel, force constant should be k double dash. Then k dash is to k double dash. So this is the spring. So the total, the constant of the spring is k. This is the original. So after what they did, the spring can be cut into three parts as a ratios of 1:2:3. This is the first spring. This is the second spring. This is the third spring. So this is 1:2:3. So here spring constant value k1, here k2, here k3. Now when they are connected in series, first I am going to take the when they are connected in series. First of all, spring constant k1 equal to 1 into original spring constant 1k. Next k2 equal to 2 into spring constant, k3 equal to 3 into spring constant k. So when they are connected in series, so its new force constant is k dash equal to, we are going to find. So formula for k dash equal to 1 by k1 plus 1 by k2 plus 1 by k3. So substitute values. 1 by k dash equal to 1 by k plus 1 by 2k plus 1 by 3k. I am going to take common as 1 by k, 1 by 1 plus 1 by 2 plus 1 by 3. Here LCM is 6. So 6 plus 3 plus 2. So on numerator 6 plus 5, 11 by 6. So 1 by k dash equal to 11 by 6 into 1 by k. So I am taking as k. So I want to k dash value equal to, it is comes reciprocal 6k by 11. This is the k dash value. Now when they are connected in parallel, when they are connected in parallel, the new force constant should be k double dash equal to k1 plus k2 plus k3. So k1 value is k plus 2k plus 3k. So total 6k. So k double dash equal to 6k. What we are going to find? K dash is to k double dash. So k1 by k dash by k double dash equal to, so k dash value 6k by 11. Here k double dash means 6k, 1 by 6k. 6k is going to cancel. So 1 by 11. K dash by k double dash equal to 1 by 11. So we can write as ratio k dash is to k double dash equal to 1:11. This is the ratio of parallel and series. Now see the options. 1:11 Option D is the correct answer. These are all different types of questions asking NEET exam in previous year questions. We will meet in next session.
Subscribe now and press the bell icon. Never miss an update.